Reese, would you like to intro?
I was up till 10 last night. I was busy. Yeah, that's
I've been recording for 5 seconds. Would you like to intro?
Yes. Wow, we love stats. Come join us on the stat voyage.
Go to the throne instead of the phone.
I love that. Thank you. Okay. So write down the first write down the first number that you think of for the following. Pick a 2-digit number between 10 and 50,
This is a game.
where both digits are odd and the digits do not repeat.
What's happening here?
I don't know what's about to happen
Okay,
next.
do we pick anyone?
Can you repeat that just one now? Wait.
It's right there on the board. Okay, what possible values fit this description? Record your answers on the dot plot on the board. I'm going to draw a dot plot.
Yes.
Okay, what was the description between 10 and 50?
Oh, no. You can do
And both digits are odd and the digits do not repeat.
Oh.
So do we give you our answers?
Not like 30, 30.
10 and 40, or
35.
43.
Hayden, you're 17.
I'm 35.
Freddie, 21. That's not, both are not odd.
Does
31.
13
Freddie.
work?
Just say 31. 37.
37. Does everyone pick a number? Now you can.
13.
Okay.
Does that work? Yes.
Yeah.
It's limiting us to a few numbers.
35. 39.
Wait, Drew, Landon, and I all did 35.
Oh my.
So sorry.
I did 31.
You just said 37, Brooks.
This is approximately symmetrical.
Okay, I said 37.
This is less cute.
Yeah.
We're starting out.
Right here.
30. Because 30 is better.
I don't know. You just like think of in the middle.
You can't do 20.
I want to do 20. But,
So here we are. If you want to record it, you can, but I'm going to move on. What do you notice about the distribution?
It's less cute.
It was left skewed. Did you
Yes.
expect this to happen?
Uh-huh.
That's exactly what you expected to happen.
I expected it to be symmetrical,
Yeah,
but I was.
People to choose in the middle.
I didn't expect
What proportion of the time would I expect to get the value 37 if the values were equally likely to occur?
I said
What
37.
proportion?
How did
Is
it
the
know
difference
we
in
would
these
choose
proportions
37?
significant? How do I know if this p hat is significantly different from the 1/8 that I expected to happen? So because there are 8 options, which we didn't actually calculate, but there are 8 options because you have 13, 15, 17, 19, and then 31, 30, 5, 37, and that's it. So that's 8 of them.
What happened to no p hat?
If you expect to happen 1/8 of the time, was 37 more than 1/8? And if we had a larger sample size, we could actually test that out. So a hypothesis test will help me decide. That's my thought bubble. That's what I'm thinking. That's what all of you should be thinking. That I thought that Drew was thinking that. I knew he was.
What's that hypothesis test?
We're about to find out. Freddie, thank you so much for asking. I'm excited to show you what a
Sharing
hypothesis test
prescription
is.
drugs with others can be dangerous.
You're
Is
telling
this a
me.
common occurrence amongst teens? That's something that we could test out.
Yes.
It's something we could
It's
do.
very
Why
common.
we want to
Or-
test that out if it's dangerous?
Or we could do
Because
a
we want to
hypothesis.
save the world.
That sells the drugs.
But her.
A hypothesis test can literally save the world, Brooks, and I just want to share that with you today.
What if what we share is not prescription?
Don't share prescription drugs.
Or any
Don't
drug
do
for
it.
that matter.
Don't do it. The National Association of Colleges and Employers stated that the average starting salary for students graduating with a bachelor's degree in 2010 is $48,351. Is this true for your college?
Yes.
So
No.
that's something that you could test out. You could take a sample from whatever your college of choice is. Maybe you want to choose a college that has a higher starting salary. How do we answer questions like these using sample data? Well, we perform a hypothesis test. So in the last unit, we created a confidence interval, and that gave us a ballpark estimate of what we think, like using a sample we already had, what we think the true proportion is. So a confidence interval was we only have a sample and we're trying to make an estimate about the population. In a hypothesis test, we are given the population and we take a sample and compare it to that. So a hypothesis test is different because you think that the population parameter is wrong. Like, I think that this number right here is wrong. I don't agree with that. And I'm very passionate about starting salaries. So I'm going to go out on my own, and I'm going to take my own sample, and I'm going to try and prove that to be wrong. So in a hypothesis test, you are given your P, you're given population, so you're given P, but your goal is to try to prove that number wrong. That's the whole goal. Yes. You think it's either higher or lower or just different.
So like disproving a fact. with
Yes.
the data.
Mm-hmm. So in this type of test, you're trying to prove it wrong, and you're given the population number. In a confidence interval, you are not given the population number. You're trying to figure out what that is. So you're only given a sample. So that's why it's different. Sometimes you can only do a confidence interval because you don't have the population data to begin with. But in a hypothesis test, you have that, and you have a sample. So you have both, and you're trying to prove the population number wrong. So that's why you would do one over another. So in the last unit, we used sample data to estimate the unknown population characteristic. In this unit, we will use sample data to test some claim or hypothesis. So we'll test the population number that's given to me already and see if it's plausible or not. To do this, we used a hypothesis test or a test procedure. So a test of hypotheses, this is just a vocab term, is a method that uses sample data to decide between two competing claims or hypotheses about a population characteristic. So what we are deciding when we take our sample, there are two possible decisions that we could make, or two outcomes. So when we take our sample, obviously the result is going to be different than the population. So if I took a sample here, it's almost physically impossible to take a sample of 200 people and get a starting salary that's exactly this number. Like, if I went to any college, if I went to A&M and I took a sample of 100 graduating students from 2017 and I got an actual average, it's either going to be higher or lower. It could be really close to it, though. It could be like 49,000. Or I could also take a sample and I could get 53,000. I could get something like that. But the chances of me getting exactly that dollar amount are very slim to none. So we already know that it's going to be a little different. However, what we don't know is it a little different but still not enough evidence to prove it wrong? So if I took a sample at A&M and I got 49,000, do you think that's enough evidence to prove that the starting salary is more?
No.
Probably not. So we say we don't have enough evidence. We just think it's a random sample and there's sampling variation. So variation just means it's off by a little, but not enough. So if I got 49,000, it's off by a little, it's not exactly, but I don't have enough evidence to prove the 48,000 wrong. And we call that just sampling variation. Or our second option, the second thing that could happen, would be that the value would be considered surprising. So that word surprising that showed up last chapter, we're now going to actually figure out what that means. So surprising means that it's not likely to occur. So maybe when I took my sample of the salaries, I got 55,000. So maybe that's enough evidence to prove that A&M, how do you say it? Do you say ATM? TAMU, okay, that makes sense, is higher than the national average.
I never knew that.
So maybe when you take your sample at A&M, you get a really high number that is what we would say is surprising, and that also gives me enough evidence, because this unit is all about evidence. Like I need enough evidence to prove that wrong. So when you take your sample, do I have enough evidence to prove that A&M is higher than the national average? And so to get 55,000, that would be considered surprising. Does that kind of make sense? This is all very conceptual, and we're going to show you the math behind it here in a second.
Does it matter how many people you ask that question to?
We'll figure that out in a minute. This is all just conceptualizing.
Murder trial.
Okay, so the first thing and one of the main differences in a write-up is what we call the hypothesis statements. We have what we call a null hypothesis. It's denoted by HO, sometimes referred to as the HO. That's inappropriate, so we just say HO.
I thought we said huh?
It's like saying ho ho ho.
It's a claim about the population that is initially assumed to be true. So in the example that we used from the first slide, it was saying that the population salary was like 48,000 something. What was it? 48?
351.
351. So that would be like, that is initially what I think is true. Or that's what is said to be true. The null hypothesis. That's the claim. Exactly.
That you disproved.
And then the alternative hypothesis, denoted by H sub A, the HA. So we've got the HO and the HA. The HA is a competing claim. So when I visit A&M, I think it's higher. So it's always going to give you a direction, higher or lower. So that would be that P is greater than 48,351. Your numbers will always match up. They'll always be the same. So this is what the claim is. Like, this is what is said to be true. But this is what I think. So this is the claim. But this is what I think, or what I want to prove. My opinion matters. So I'm going to prove that wrong. Then you also have to define what P is. So do not forget to define the P. Define the P. So I'm going to say where P represents the true proportion of starting salary at Texas A&M. Just making that up, but
So just write this on.
so this would be the beginning of the free response.
You have another right after this, Shelby?
Oh yeah,
Write-ups never end.
they never end. So you're usually trying to determine if this claim is believable. The hypothesis statements are always about the population, never about the sample. I want you to write that down. If you defined P as the sample of, like if you used a P hat or you said that it was a sample of A&M students, then you would get 0 credit for it on an AP exam. So we are always making a claim about the population. And our sample is a supplement to help give us evidence. Let's consider a murder trial. What is the null hypothesis? So this is what you assume
He murdered someone.
is true before you begin.
Innocent.
That they're innocent. Because innocent until proven guilty, right? So you have to assume that they are innocent. But what is my alternative? Like, what am I trying to prove?
They're guilty.
That they're guilty. So my null hypothesis would be the claim is that he's innocent, but I'm trying to prove that he is guilty. Or she. I'm sorry. Just came out.
That was
Wait, is
an
this from the
unintentional
judge's
bias.
perspective?
So, to determine which hypothesis is correct, the jury will listen to the evidence only if there is evidence beyond a reasonable doubt.
Mr. Lee.
Would the null hypothesis be rejected in favor of the alternative hypothesis? So you have to have enough evidence to reject the null hypothesis or reject the hoe. If you do not have convincing evidence, then you would say that you fail to reject the null hypothesis. You fail.
Reject the hoe.
You don't always reject the hoe.
You should.
If you
See, that's what
do
we're
not
saying.
reject the hoe and you don't have enough evidence, then you fail to reject the hoe.
Wait, so do you want us to reject or not reject?
Because think about this.
Always reject.
I'll show you when it is acceptable to reject
You
and
want
fail to reject.
the hoe. That's the goal.
Because
Yeah,
listen,
there you go.
I think.
you are either guilty or not guilty, but you can never prove innocence. Does that make sense? That's why you don't accept the null
So
hypothesis.
you want to reject the hoe because you're trying to get your
Yes,
opinion to be
you want to
right.
reject.
What
You
would
prove
not
guilty
reject
or
though?
not guilty, but you don't prove
If
innocence.
you
If
prove
they're
them
not guilty, aren't they innocent?
Not necessarily.
I don't know. If you can prove that they're not
O.J.
guilty.
Simpson.
OJ.
But they didn't.
Wait, is
they
it-
didn't prove.
But they didn't prove his innocence, they proved he was not
So
guilty.
when do you fail to reject the hoe?
I'm going to show you. Thank you for
But if you
asking.
have, like, evidence
So
showing
we
that
will
you
make
didn't do it.
one of two decisions.
Wait, I'm
We will either,
Reject the hoe or
just
not reject the
stay with me.
Okay.
There are two decisions we will make. We will either reject the hoe or we will fail to reject the hoe. Those are the only two decisions that we make in this chapter.
50% of each.
No, not 50%. That is not right.
I think he's right.
No.
Brady's convincing me it was 50-50 thing.
Okay, I've already drawn these up.
Yeah, it's true.
The null hypothesis is that the population characteristic, so your P equals a number. Make sure that you use P and not P hat.
So the p-hat's done.
P hat is done for right now.
Forever.
No,
Okay, so alright, P on this test is better not get points off.
right. Don't add a hat or I'll take off. Then the alternative is either greater, less than, or not equal to. If it's a greater or less than, we consider that to be a one-tail test. Yes.
If it's not equal to, then it would have to be either greater than or equal to. So why is non-equal separate from greater than equal? Less than?
Good point.
Because it could be either direction. So I'm just claiming that it's different. That's another good point that I did not bring up. But don't put greater than or equal to or less than or equal to. It must be greater than or less than.
No p-hat.
So let's practice writing some hypothesis statements. Is the proportion of students who answered 37 higher than the expected proportion of 1/8? So my null hypothesis, P equals what? What's my proportion that the claim is? 1/8. And my alternative is my HA, and what direction does it go?
Higher.
Higher, so greater than 1/8. I usually circle that in my problem
Wait, how do we know it's greater?
because it says higher. So I'm trying to prove that people that answer 37 are higher than the expected value of 1/8. And what's the last thing that I have to do?
Define the P.
Define the P, so where P represents the
Oh, so we have to write
true
this every time.
proportion, and this never changes.
Yes.
This never changes right here. So this will always be the same. Proportion of, and then this is where you insert the context. So what does P represent?
Of questions.
True proportion of students who answered higher than 30.
Yes. Students who answer 37. Not higher.
Oh.
Yes. Very specific.
Make sure you include period as well.
Good. Or you could say, will answer. Something that you cannot put. Do not use past tense. I'm going to put that in all bold. Do not use past tense. So do not put answered. Who answered 37? Don't do it.
Why is that?
Because that indicates that it's in the past and it's already happened, but we're trying to prove what will happen or is happening at this moment in time.
So, where P represents the true proportion of
People who answer or will answer.
who answered 37 questions.
But don't put answered. Never past tense.
No,
AP graders will answer is fine,
Yeah.
but not answered.
Answer or will answer?
But wouldn't it
Yes.
be more than 37?
Everything I would think.
Do what?
Why is P 37?
I guess what wasn't that?
We think that it's more than that.
So shouldn't the P be where it's defined as who answered more than 37 questions?
No, answer is like when they choose two random numbers, they're choosing 37. So I think that 37 is chosen more often than the other numbers. Okay, let's try another one. Sharing prescription drugs with others can be dangerous. A survey of representative sample of 592 U.S. teens ages 12 to 17 reported that 118 of those surveyed admitted to having shared a prescription drug with a friend. It's terrible.
No.
Gosh. That's a lot of people. There must have been zero bias in this because
90% of that was
there could be
probably
some response bias if you got somebody asking.
What about
Is
undercover
this sufficient
response?
evidence that more than 10% of teens have shared prescription medication with friends? So there's a lot of stuff in here, and this is what a typical prompt would look like. There's several numbers in there. So we got to be able to pick out the numbers that we need for the hypotheses.
Scratch out
Five,
that 12
nine,
and
Yeah,
17.
scratch out.
Don't scratch it out because we need it.
Oh, for the proportion.
Yeah. So what is the claim? How many people share prescription drugs with friends? P equals what? 10%, so 0.10.
Oh, that works.
And my alternative, I'm trying to prove that it's what?
It's greater than.
Because it says more. So greater than 0.10, where P represents the true proportion. I cannot spell. Of teens who will share or who share but do not say have shared. Don't say have shared.
So we don't do any math. This is it, right?
Oh, we do math. We're just not there yet.
How many slides are we doing?
All of them.
What? Also pages.
I think so.
Just 24 pages.
You want me to teach?
Okay, good with that one? Okay, next one.
We'll start filling.
Next one, try this one. We can just talk about it out loud.
There we go.
What is that?
People who purchase this brand would be unhappy if the bulbs lasted less than 8,000 hours. So my null hypothesis would be what?
P equals 8.
Oh, all we're trying to do here is just non-equal. So it's not greater than or less than, correct?
It does say less than. However, is this a proportion or is this something
Oh, I'll do
else?
the next one.
It's
It's something else.
Oh, it's just
a
data.
number.
Is it a proportion? Does it give me a decimal?
No.
But it's saying, what's in the quotations right there?
Average life.
Average. And what is average?
Yeah, P.
Not P, it's
X.
P hat.
mu.
Yeah.
Whoa, mu. So in the next unit, we'll start talking about means. This is just there to help you discern. It's not always P. In this unit, it is. But it would be different because it's talking about the average life. That's saved for chapter 11. Just like to throw that in there.
This one.
Is this gonna be on the problem set though? Will you do this to us on the problem set?
I could.
Here we go. There we go.
Okay, next one. Here's another mean one.
No, it's equal.
This is an example of a not equal. So if it says if the mean diameter is not 3 inches, the production will have to be halted. So if it's larger or smaller. So that's where you would have a not equal to instance. Okay, we're going to look at some different examples and tell me whether these hypotheses are legitimate or not.
No.
this one good or no?
No.
No.
What's wrong with
No.
it?
No,
Greater than or equal to.
Ew, get that equal sign.
Sad face. This one.
No.
Because
No X bar.
no X bar. You would put mu instead of X bar.
Oh.
That's got to be population. This one.
Yeah.
Yes.
Yay.
So we see.
Yeah.
Yes.
Yeah.
No, but what's the reason why?
Oh, they're different numbers.
They're different. 2.3 and 3.2.
Oh.
Got
Must
pranked.
use the same number. You got pranked. What about this one?
You can't do that.
No.
No, because
Not order.
they're not equal. They need to be flipped.
Oh.
So it must be equal and then not equal.
C.
So the null hypothesis is always equal.
That's
Okay, some facts to remember. Hypotheses always refer to populations, never samples. Never
So
ever
you're never
samples.
going to use your sample, like, statistic
Hmm
symbols.
The alternative hypothesis is things that you're trying to verify or you're trying to prove. So I want to prove the null wrong. And you always define your parameter in context, present or future tense, so no past tense. This is a really good slide to highlight or star.
Got it.
Very many concepts. Okay. So, we're going to get into yes. Remember the sampling distribution formulas? There's a little bit of that in this chapter. So we learned it all last chapter, but you could be responsible for sampling distribution questions on this test. Okay, so Freddie, what did I just say?
It's on the next test.
What's on the next test?
That.
What's that?
Standard deviation of p
the
hat
formulas,
equals
we must know that.
P1
Right, so
equals
sampling distribution questions will be on this
But
test.
that's even though that's on the formula sheet.
Even though it's on the formula sheet, it's still going to be on the test.
So there is
With new
p-hat.
information or just
When
old
n is large, the sampling distribution is approximately normal. How do I know how large it is? What do I have to check?
And times
P and 1 minus
P
p.
hat must both be greater than 10.
No, yes.
Good.
Whoa, there is a greater than.
Yes, sir. Drew.
Yes.
Sir.
Good, good, good.
I do that.
So sampling distribution problems will still be on the test. I want you to write that at the top. Because I don't want you to just study hypothesis tests and then be surprised when it comes time to it.
So basically, there's no.
Here's the formula for the hypothesis test. So we're going to kind of discuss what that means.
You don't memorize that, right?
No, it's on your formula chart. Actually, I'm going to pass that out really quickly. So the back on the inferential statistics, it says standardized test statistics. So that's what you're trying to find. So this Z right here is called the test statistic. And I will refer to that on a test very often or on a problem set. So Z is our test statistic.
Is that different than the ZZ?
This is way harder than that.
It's different than a Z score, yes.
No, Z on
Lots of Z's. Okay, then you'll see statistic minus parameter. P hat is our statistic because it is a what? It's a sample. Thank you. Minus parameter. This is a parameter because why?
Population.
Population. So the statistic in this chapter is P hat. The parameter in this chapter is P. Divided by the standard deviation of the statistic. If you go down to that first chart, it gives you the standard deviation of statistic right there. So if you can read this formula chart, then you really don't have to, if you know what a statistic and a parameter are, then you really don't have to memorize anything. Okay? So try to use the formula chart as much as you can. Okay, so here we're actually going to calculate the test statistic. So here's an example. In June 2006, Associated Press survey was conducted to investigate how people use the nutritional information provided on food packages. Interviews were conducted with 1,003 randomly selected adult Americans, and each participant was asked a series of questions involving two. So when purchasing food, how often do you check the nutritional label? And how often do you purchase food that is bad for you?
Even after you take the label.
It was reported that 582 responded frequently to that question.
No way.
441 responded very often or somewhat often. Checking labels, I would say never. Probably.
I mean,
I
if
don't-
it's like a brand name that I know, like I'm not checking.
I just don't check the nutritional labels often.
That's what I'm concerned.
So the question that arises is it reasonable to conclude that a majority of adult Americans frequently check nutritional labels when purchasing packaged food?
Based on this data.
A majority would be, I guess.
So majority,
Yeah, that is majority because it's over 50.
majority means 50%. So anytime you see majority, you might want to make yourselves a note. Majority means 50%. And then I want to find more than majority. So I'm going to kind of take you through this. We're not doing a full write-up together yet. I'm just going to kind of take you through what it looks like, and then we'll do one together at the end of class today. Where P is the true proportion of Americans who frequently check. Then when I took the sample, how many of them said that they frequently check?
582.
And so 582 out of 1,003. So 58% in my sample said that they did. And so what I want to do, that 58% I'm comparing to the 50%. And I want to know, does that give me enough evidence to prove 50% wrong? Can I prove that the majority do?
Yes.
Based on my sample?
Yes.
And I don't know yet. I've got to mathematically figure that out.
Why are we using P?
I think yes.
With your thing.
But with math and things, I'm going to actually mathematically check if I have enough evidence or not. Or is it just from sampling variability? So is it unusual? Is 58% enough evidence or not? So we're going to create what we call the test statistic using our numbers. This test statistic, and I want you to write this down, unless it's already there. I think it's on the next page. This is the formal definition of a test statistic, and it does show up. Okay, so a test statistic, please write this down right here. It is how many, so that's why it's a Z, because it's how many standard deviations the sample is from the population. So like if I had a normal curve and 0.5 was in the middle and 0.58 is here, it's like how many standard deviations am I away? That's what this number is getting me.
How many do you need to be away?
That's a good question, Reese.
Is it 2?
There's not an exact number, but we'll figure out if it's enough or not.
Is the after sales statistic supposed to be p-hat?
Nope. Wait. Yes. Sorry. The hat's right here. Do you see that? I don't know. There he is. He needs to come over here. Thank you, Hayden. You got my back. Okay, so when you calculate that, you end up getting 5.08. So my sample is 5 standard deviations away from my population. Does that seem like a lot?
Yep.
Yeah, it is a lot. Quite a bit. So from that, so here we have our test statistic. There's a second. So when you're doing the calculations portion, you're going to be doing 2 things. You're going to find the test statistic. From that, we calculate what we call the p-value. And the p-value is the probability of obtaining the test statistic or something more extreme, assuming that the null hypothesis is true.
Is that in there?
Would you write that too?
Yes. Okay, so yeah, you don't have to write any of this down. Page 49.
Just don't know why is this in here.
Very important page. So we're going to get to that, don't you worry. Page 49 is a very important page. Memorize it. So you don't have to. Okay, so let me explain what a p-value is before we move on. A p-value, like when we get our test statistic, we are 5 standard deviations away. So our sample is 5 standard deviations away from population. I need everyone's eyes on me. This is important because people don't understand the p-value, and you have to take the AP test. You have to. So what the p-value is based on this number, The p-value is the probability of getting 58%, assuming that the 50% is true. So the chances of me taking a sample and getting 58%, it's either likely to occur or it's very unlikely to occur. And so if you get a really small probability, then that is going to give me evidence to prove the 50% is wrong. Does that kind of make sense?
Yep.
If you get a high probability, like if my sample were really close to my population, then I'm going to get a high probability. So maybe if I got 51%, it's so close to 50% that the chances of me taking a sample and getting 51 is really high. So I don't have enough evidence to prove the 50% wrong. But the further away my sample is to my population is just giving me more and more and more evidence to prove the population wrong. Does that make sense? Kind
So
of.
are you talking about when you plug it in the formula, the answer you get tells you?
Yes. So I'm going to calculate a p-value. This is where my sample is in regards to my population. So 5.08 is all the way out here. So it's probably very likely, and it actually is 0. Now, how did I get that number? We're going to do it in the calculator. So to get my p-value from this test statistic, it is normal CDF 5.08 to infinity 0, 1. It's on the board. No, it's not. What you type in the calculator to get your p-value, normal CDF 5.08, 5.08 to infinity 0 and 1. And what that's doing is it's calculating the probability at this z-score and then everything more extreme than that because it is a right tail test, or it's going to infinity.
So Z does mean Z-score.
Yeah. It's how many standard deviations away
So
your sample is from your population.
finding the z-score.
So you have found the z-score, and then you're finding the probability of getting that z-score or something greater than that.
So do you want them high or low?
You want it to be low. You want the p to be low, and you reject the ho.
Oh.
So is it always going to be the Z as the lower bound?
Unless it's a negative z-score, like you do a less than test, then it'll be the upper bound.
Wait, Ms. Long?
Yes.
So is it like, if it's a high if the p-value is high, that means there was a high probability of getting that, which is like, oh, it could have just been
Yeah,
the
it could have just been the
same.
sample
But
I
if
took.
it's not likely, then
You get a low probability, so you reject.
So you obviously failed the hypothesis.
Yes.
You're like, oh, yeah.
So then our conclusion is, since the p-value is so small, we reject the null hypothesis. There is convincing evidence to suggest that the majority of adult Americans frequently check the nutritional labels on food.
To write all that for response.
We're going to go through a free response together, so you don't need to write it down just yet.
Okay, I'm confused. Since we had a low number of it being above our Z-score, wouldn't that mean that they have...
So that means that our sample was so surprising that I have enough evidence to prove the population wrong. Like the chances of me getting that sample, assuming that 50% is the number of people that check the nutritional label, is unlikely to occur. So my sample that I took is so far away from the population that I have enough evidence to prove that 50% is wrong. And so the alternative hypothesis, I've proved it wrong. I have enough evidence, so I can reject the null hypothesis.
Wait, but why does having the sample so far away mean that you reject the...
Because it's so far away from the population, so I have enough evidence. My sample that I got is very unlikely to occur, given that 50% check the labels. So that must mean that it's not 50%, it's higher than that. Okay, so if you do a greater than test, you go to positive infinity. If you do a less than test, you go to negative infinity. If you do a not equal to test, then it's on both sides. So let's say that I got like z equals 1.52 when I did my test statistic. So I'm at 1.52, and then this would be negative 1.52. To find the area to the right and the left, you would have to double. So to find this area, it would be normal CDF, 1.52 to infinity, 0 and 1. If I multiply it times 2, that's going to give me this area too. So in a not equal to test, you double the area, or you double your normal CDF, and you have to do that by hand on a not equal to test. So please write that down. Okay, so now how do I know, like based on my p-value, how do I know if I have enough evidence or not? This is the number that you've all been waiting for. The level of significance, and this is on page 49, it's the amount of evidence necessary before you begin to doubt that the null hypothesis is true. It's the probability that we will reject assuming that the null is true. We call that alpha. It can be any value and it will be given to you. So, alpha, so in the problem it's going to say alpha equals 0.01 or alpha equals 0.05. If my p-value is less than that number, then I reject. If it's greater than that number, then I fail to reject. So if I have this, if I have a number line right here, here is 0.01. If I get a p-value greater than that, then I make the decision to fail to reject. If I get a number that is less, then I make the decision to reject. So the little catchphrase is when P is low, reject the hoe. And I promise you, you'll never forget it.
What letter is that?
P, like the P value.
That one purple?
Alpha. That's my alpha. Isn't it beautiful? I just kind of make like a little fish, is basically what I think of. Yes. So when your p-value is less than alpha, you reject. If it's greater, then you fail to reject. Because remember, you want your p-value to be small. You want the probability of getting that sample to be small because then that gives you enough evidence to reject the claim that is made.
Where did alpha come from?
Alpha is given to you. The most common is 0.05. So if it's not given, use 0.05. If it's not given, use 0.05. Sometimes it's not. That's the most common one. So here are just reiterating again, if it's greater, you fail to reject. If it's less than or equal to, then we reject. We also say, so I want you to write this below it. Sometimes they'll say, are your results significant or statistically significant? So to reject is to say that you have statistically significant results. So to reject is to say that you have statistically significant results. And you might see that written that way on a multiple choice question. So I want to show you all the different ways they might ask you. If you fail to reject, then your results are not statistically significant. Basically, there is no significance if you did this test and you failed to reject. No one cares to read about it. We only want to hear success stories. Okay, never accept the null hypothesis or the hoe. Never accept, never accept. If I see the word accept, I will literally rip your paper up and throw it at you in front of the whole class. I'm going to be so mad. Don't accept the hoe. Don't do it.
Did you say the same thing about correlation?
Yes, yes. You think that I make a big enough deal about it, but I still see it. If you write the word accept,
You did this to us on
I will
the
publicly
one grade,
humiliate
it
you.
was like that really low key, but the word cause, and we were like, no.
Yes. So, in summary, here's what we have. Null hypothesis, test statistic, greater than, less than, not equal to. Now we're going to go through a write-up together. You do your so the steps for write-up, you do your assumptions. One positive is that they're the same assumptions from the last chapter. Yay. And population is at least 10 times. Then you do your calculations. Write your hypothesis statement, calculations, conclusion. I'm flying through this because we're going to do one together, and I want us to have ample time to do that.
You're flying to it.
This is the formula. We've talked about that.
And so we're back on, after all these notes, aren't we back on schedule?
Yes.
Okay, well then, that caution's messed up again. Because you did everything back a day.
I'll think about it.
What?
I haven't decided yet. I haven't decided
What?
what I'm going to do. Then write your conclusion, the decision being made.
Oh, that's
You must link it to the p-value and then context. So this is the conclusion script. Since the p-value is less than or greater than alpha, I reject or fail to reject the null. There is or there is not sufficient evidence to suggest that. And then you write the alternative hypothesis in context. Don't just write the ha.
So what is the p hat that we had to find?
It goes in your formula.
Did we solve for that?
Yes.
Using like this amount of people out of
Mhm.
this group? Okay.
Okay, so what we're going to do now